Can you solve this classic math Olympiad problem? We are given an equation, the square root of k plus the square root of negative k equal to 16. And our goal is to find all possible values of k. You can pause the video and take a moment to think about it, and when you're ready, you can always come back to verify your answer. Alright, let's solve it step by step. But before we begin, let's shift this variable term, the square root of negative k, to the right-hand side. So doing this gives us square root of k equals 16 minus the square root of negative k. Now to eliminate the square roots, we'll square both sides of equation. So on the left-hand side, squaring the square root of k simply gives us k. And on the right-hand side, we'll use the algebraic identity a minus b squared equals a squared minus 2 times a times b plus b squared for squaring this binomial. Here, a is this 16, and b is the square root of negative k. So now our right-hand side becomes 16 squared minus 2 times 16 times the square root of negative k plus the square of the square root of negative k. Now let's simplify each part. 16 squared is 256. Negative 2 times 16 is negative 32, so we have negative 32 times the square root of negative k, right? And the square of the square root of negative k simply becomes negative k. So now the entire equation becomes k equals 256 minus 32 times the square root of negative k minus k. Now subtracting this negative k from both sides, we have k plus k equals 256 minus 32 times the square root of negative k. That simplifies to 2k equals 256 minus 32 times the square root of negative k. Now dividing both sides of the equation by 2, we get, on the left-hand side, 2k divided by 2 gives us k, and on the right-hand side, 256 divided by 2 is 128, and 32 divided by 2 becomes 16. So we now have k equals 128 minus 16 times the square root of negative k. Let's now bring this 16 times the square root of negative k to the left-hand side, and the k to the right-hand side. So we get 16 times the square root of negative k equals 128 minus k. Now let's square both sides again to eliminate the square root. On the left-hand side, 16 squared is 256, and this square of the square root of negative k is simply just negative k. So now the left-hand side becomes 256 times negative k, or negative 256 times k. Now, again squaring the right-hand side using the identity, a minus b squared equals a squared minus 2 times b plus b squared. This becomes 128 squared minus 2 times 128 times k plus k squared. 128 squared is 16,384. 2 times 128 is 256. So the right-hand side becomes 16,384 minus 256 times k plus k squared. Equating both sides, we now have negative 256 times k equals 16,384 minus 256 times k plus k squared. Did you notice something? This negative 256 times k appears on both sides of the equation. So canceling this out, we are left with k squared equals negative 16,384. This can be rewrite as k squared equal to negative 1 times 128 squared. Now taking the square root on both sides of expression, we get k is equal to plus or minus 128 times the square root of negative 1. This square root of negative 1 is the imaginary unit, commonly denoted by the letter I. So our final answer is k is equal to plus or minus 128 times I. And that's it. We have found both possible values of k, which is plus 128i and minus 128i. Pretty amazing, isn't it? Even though we started with an equation involving 2 square roots, a little patience and some algebra helped us crack it wide open. But wait, before you go, I have one more bonus challenge just for you. Can you find value of k in terms of the x instead of number 16? Think it through and drop your answer in the comments below. Let's see who can figure it out. If you found this explanation helpful and learned something new, don't forget to hit that like button, share it with a friend, and subscribe for more mind-bending math questions. Thanks for watching, and I'll see you in the next video.